So in the previous lecture, we have started the analysis of rectangular dam. We have seen that in a rectangular dam, there are two major forces which are acting. One is the lateral thrust due to water, P, and another one is the self weight of dam, W. Now the resultant of these two forces, P and W, the resultant force is R. So R is the resultant force. Now this resultant force is crossing or touching the base at point E. Okay, it is acting at point E. So the distance from center of the base to the point E is called as small e, and we all know that small e represents the eccentricity. So by using Varignon's theorem, we have found out the value of small e. Now this same thing, this base, we will draw it here separately. So this is the base. This point is point A. This is called as hill or toe. This is called as hill, and this is called as toe. Now at the center, we have seen that there were two forces. Now what we will do, we will only draw the resultant force. So the resultant force is acting, the resultant force is acting in this direction. So this is the resultant force. Up to this we have completed, and this distance is called as eccentricity E. So distance from O. Now if we resolve, we will write it here. Resolving R, we get two forces. One force will be horizontal component, and second force will be vertical component. ओके बघा, इनिशियली काय केलं आपण, P आणि W चा रिझल्टंट फोर्स जो आहे तो घेतला R. नाउ अगेन व्हॉट वी आर डूइंग, वी आर रिझॉल्विंग द E force, or we can say the force, resultant force at E. So it will also get resolved into two components. One will be horizontal and one will be vertical. So now the horizontal component will be P, and the vertical component will be W. So we'll mark it here at point E. At point E, there is this vertical component, that is W, and one horizontal component, that is P. Now this P and W are acting at point E. Now write down the next point. This P force, it is resisted. So that means या P force ला resistance कशाने provide केला जाईल? It will be resisted by frictional resistance. Okay, so P is resisted by the frictional resistance, and this W, it is resisted by normal reaction. Normal reaction by capital N and frictional force by capital F. So quickly we will see these both things. बघा, आपण मेकॅनिक्स मध्ये we have seen these topics like this, कि if a box of weight W is resting on a surface, then we can draw the free body diagram. Let's say it is moving also. If it is moving, then this is the box W. There is a weight which is acting, the weight of the box, and there will be one normal reaction which is acting from the surface. Okay, this is the force P. Now to balance this force P, there will be some resistive force which is acting, and that is called as frictional force. ठीक है, जे काही घर्षण तयार होणार during the movement of this block and the surface, that is called as friction force. So this will also take place in the dam also. आता डॅम मध्ये आपण बघितलं की the water was applying pressure from this side. That means the dam is trying to move from left side to the right side, that is from A to B. आता ज्या डायरेक्शन मध्ये मूवमेंट व्हायची शक्यता आहे त्याच्या अपोजिट डायरेक्शन मध्ये फ्रिक्शनल फोर्स ऍक्ट करते. दॅट मीन्स फ्रिक्शनल फोर्स विल बी ऍक्टिंग इन दिस डायरेक्शन. So this P force, it is resisted by the frictional force, and this W force, it is resisted by the normal reaction. Now these points are not much important right now, but just for your extra information I have given it. Now the next point is very important. So next point talks about that the horizontal force P, the horizontal force P, it does not contribute, it does not contribute. कशात contribute करत नाही? It does not contribute in generation of stress at the base. म्हणजे जे काही आपण सिग्मा मॅक्स आणि सिग्मा मिनिमम काढतो त्याच्या कॅल्क्युलेशन मध्ये हा जो हॉरिझॉन्टल कंपोनेंट आहे आर चा, दॅट इज पी फोर्स, सो दिस इज ऑफ नो यूज. So we don't have to take this into our account. So what is important to us now? The hence stresses developed at base, stresses developed at base are caused, they are caused by only W, that is self weight of dam. Self weight of dam. Now just pay attention here. This P force, now this P force is not of any use for calculation of stresses. Calculation of stresses at base साठी हा P force जो आहे आता कामाचा नाही आहे. So what I am doing is I am removing that and I am only drawing the W force. So this is O, this is A, and this is B. Now this W force, it is acting here. It is acting here. What was the shape of the dam? Cross-sectional shape. It was rectangular. If we draw the top view, जर आपण top view draw केला याचा, so it will look like this. Okay, what is the width here? The width is B, so that means the total width is, this is B. This is the centroidal axis and this is the eccentric axis. Now if you correlate this with the original standard problem, we can clearly see that this distance is the eccentricity, and this W load, the load that is acting here, this is an eccentric load. This W is eccentric load. एक कॉन्सेंट्रिक लोड असते, एक इसेंट्रिक लोड असते. सो दिस W कसा आहे? हा W आहे इसेंट्रिक लोड. नाउ इसेंट्रिक लोड आहे, that's why what will happen? It will cause which type of stresses? Both type of stresses. It will cause both direct stress and bending stress. So it will cause both direct stress and bending stress. So this is A point, this is B, and this is O. This is the cross section, or we can say this is the plan top view. The force is acting here, W, and this is the eccentricity. Now this dimension is b and this dimension is 1. Why 1? Because we have considered the length of the dam as unit length. एक assumption लिहिलं होतं आपण note. We will always consider the unit length of dam. So L will be equal to 1 meter always. Now from here it is very easy. What is the moment M? What is the moment M here? M is equal to W into E. So this is equal to W into E. We can even substitute the value of E here. E calculate केला है अपन in the previous lecture. E is equal to P by W into H by 3. P by W into H by 3. So this W and W will get cancelled. काय उरलं इथे? PH by 3. So this M is equal to PH by 3 or W into E. Both are correct. Now second is what is ZY? ZYY is equal to DB square by 6. General formula DB square by 6. But the value of D is 1 and B is as it is. So it will be equal to B square by 6. B square by 6. Now we will calculate sigma max. It is equal to sigma naught plus sigma B and sigma minimum is equal to sigma naught minus sigma B. So direct stress, it is equal to force per unit area. What is the force here? W. So W divided by area. What is the area? Area is B multiplied by 1. So B multiplied by 1. So W by B. Bending stress, same M by Z. The value of M is W into E or PH by 3. We will take here W into E. Z value is B square by 6. B square by 6. So it will be 6WE by B square. So both we have got the values now. Substitute it here. W by B plus 6WE by B square. W by B minus 6WE by B square. आता W by B जर कॉमन घेतला आपण W by B, so it will be 1 plus 6E by B. 1 plus 6E by B. Similarly, here will be 1 minus 6E by B. So these are the final stresses that are acting at the base of the dam. So maximum stress is W by B into 1 plus 6E by B, and second sigma minimum W by B 1 minus 6E by B. बघा एक अजून गोष्ट सांगायची राहिली आहे, so that I will cover it here. That is how to calculate the weight of the dam. Weight of dam W. So same formula we will use. It is equal to whatever is the material. So generally the dam is made up of concrete. Okay. So dam generally आपण कशाचं बनवतो? Concreteचं बनवतो. So for concrete, unit weight of concrete will denote it with gamma C. So unit weight of concrete is gamma C multiplied by volume. Multiplied by volume. How to calculate the volume of dam? Volume is equal to this B into H. आता H कोणता वापरायचा इथे? Capital H. B into H into 1. So this will give us the weight of the dam. And while calculating the P, that is resultant lateral force due to water, what is the formula? Half into gamma H square. This H here what we are using is not the capital H, it is small h. म्हणजे ज्या हाईट पर्यंत वॉटर आहे फक्त तेवढंच घ्यायचं, स्मॉल h स्क्वेअर. नाउ हियर यू पे अटेन्शन, इथे कन्फ्युजन नाही झालं पाहिजे. हियर बोथ व्हॅल्यूज आर गामा ओनली, बट दिस इज गामा C and this is gamma W. Okay, so once again I will write it here, half into gamma W into H square. Gamma W is unit weight of water. सो प्रॉब्लेम मध्ये काय दिलाय ते बघायचं, गामा C दिलाय की गामा W दिलाय, that you should see and accordingly you have to solve. Okay, gamma C it is used for calculation of weight of the dam. Weight of the dam काढायसाठी it is used, and gamma W, it is used for calculating the lateral thrust. So with this, now we have calculated the maximum stress and minimum stress for rectangular dam. Now in the next lecture we will be seeing how to calculate the stresses for trapezoidal dam.